This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring new information that will expand your skill sets and toolbox and share the stories of fellow network engineers.
Hey everyone, welcome. Thanks for joining. This is the end. We made it. It's been 3 days. I'm Eric Reagan. I'm on the board at KTech here. I think I've met most of you over the past 3 days, but thanks for joining us here tonight. And for the folks on Zoom, thanks for joining us. This live event is part of a 3-day series called KTech Connect with the Art of Network Engineering. It's hosted by the Knoxville Technology Council in partnership with the Art of Network Engineering podcast, which we've got here to my left. KTech's mission is to connect, develop, and promote and advocate for technology industry in the greater Knoxville region. We believe that the tech industry is essential for our community to thrive. It's our goal to unite technology leaders and empower businesses to advance this area as a technology hub and a center of innovation. We've enjoyed getting our hosts to host the A1 team, our sponsors, presenters, and everyone else who's joined us for the week. And now I'm going to pass things off to Bob Hennessy, the regional sales manager with Open Gear, one of our sponsors this week.
Thank you. Good afternoon, everyone. First off, thanks for taking time from obviously very busy schedules to be here through the multiple events that we've had. KTC did a great job setting this up, and we're very proud to be a sponsor for A1 and what they're looking to do out there. So who are we and what do we do? So we manufacture console servers that allow customers to have out-of-band capability to all their IT assets. In essence, we provide secure remote control and access to all your IT devices. Networking gear, all sorts of networking gear. You may have servers with iDRACs or ILOs in them. We give you that access as well. PDUs, UPSs, really anything that's got a console port on it, we can connect to. Also, we have USB connectivity and Ethernet connectivity. So there's 3 different ways that you can connect your variety of devices to our product. Where do we play? We do a big business with companies that have an issue and they've got to roll a truck. And the time and cost associated with that can be very cost prohibitive. So what we allow you to do is we allow you to come in remotely as if you were at the data center site with your laptop connected in the console port of the server. We do it remotely. We don't sell direct. We sell through our channel of partners, VARs, resellers, managed service providers. If there's an interest after the event today, certainly we'd love to talk with you and see if there might be areas we can help you. Certainly after the event, we'd be more than willing to set up a call and speak with you folks and see what Open Gear can do for you. Thank you. I'll now turn it over to Taga, who's the regional director at Alkira.
Oh, wow. Thanks, Bob. I'm Taka Yamada. I'm director for Alkira. Here with me, too, is in the crowd William Collins, the technical evangelist for Alkira. Real quickly, basically, what is Alkira? So in the traditional way, if you wanted to connect your network or your on-prem site to something, you would have to get a router, a switch, a firewall, DNS, all that. Alkira provides all that through our cloud without having the customer having to add any hardware or software. Basically there's a lot of different acronyms out there, but it's network as a service. If you haven't had time, please go by our booth. We are giving a PS5. I'm shocked I got it here without my son stealing it, but he was going to be stuck with his Xbox. Life is tough. But without further ado, it's my privilege to introduce the A1 team: AJ Murray, Andy Lepef, Dan Richards, Tim Bertino, and Alex Perkins. Thank you.
None of this would have been possible without them at all. So just a huge thank you to Eric and Jenna from KTech. Eric came to me earlier this year and said, "Hey man, I got an idea," and here we are. So thank you so much for the sponsors and
do you think he regrets it? He looks exhausted.
That was a very thumbs up. So I'm AJ Murray. I'm the co-host and creator of the Art of Network Engineering podcast. Right here to my left is Dan Richards. He's part of the original team of the co-hosts. This is Dan Pelfrey. We'll talk about him a little bit more in a little bit. Over there is Andy Laptev. He's also one of the original co-hosts and co-creators of the podcast as well. Alex Perkins is new to the A1 family. We started another podcast this year in January called Cables to Cloud. So if you do anything with cloud or network engineering, you should definitely subscribe to their podcast as well. And then over there on the end is Tim Bertino. And Tim joined us early on in our journey as a listener. He then came on board and wrote some blog articles for us. We interviewed him in his very own episode, and he flipped the script on us and started asking us questions. And we're like, wow, man, that was really cool. He asked some really cool questions. He's very engaging. And so we invited him to be a part of the show, and it's worked out ever since. If you've watched the show or listened to the show for any length of time, you might be familiar with some of Tim's introductions. And if you wanted to be an actor, he could have. If for some reason network engineering didn't work out, he could go be an actor, and I think he'd do very well at it.
Oh, yeah.
Unfortunately, Lexi could not join us this week, so Lexi Cooper, better known as @TrackItPacer, she joined us towards the end of 21. Sorry. But we only have so much PTO to go around, right? So she was not able to come out here with us and be at this event. But she is here with us in spirit, and I'm sure she's watching online. So hi, Lexi. So how this thing started, it was just before the pandemic. Myself and I know Andy, I followed Andy on Twitter, and we were both miserably failing the CCNP, the Cisco Certified Network Professional exam. And I saw some other people that were studying for it, and I said, hey, do you guys want to start a study group? Maybe we can help each other out. Now, I don't know why I thought that getting a bunch of people together that fail an exam to try to pass an exam without inviting somebody who did pass the exam to help us study was a good idea, but in the end, it all worked out. What was really cool about that study group is that I had certain strengths that I could teach them. Others in the group had certain strengths, and they taught me, and it worked out really well. But then the pandemic hit, and we were like, wow, I think we're going to need this study group a whole lot more than we think once we're all locked at home. And a few weeks into the study group and the pandemic, we're having these really fun conversations. And I had an idea a long time ago about a podcast, but I knew that I needed more people to do it because no one wants to listen to me for an hour. And so when I pitched the idea of the podcast, every single one of them was just like, hell yeah, let's do it. This is going to be fun. And it's weird how it was like all the right people that came together, because one of the original team members was a radio DJ in college, and he's like, I know how to do this stuff. I know how to edit and put together a radio show. And we're like, what? And so it's weird how it all worked out. Let me check my notes here. So today, it's crazy to think that a organization such as KTech would invite us out to be kind of the headliner for an event. And we have several thousand downloads every month of our episodes. We have sponsors, some very large sponsors coming and working with us. So it's really crazy to think that we started as a study group and now we're where we are today. And it's even crazier to think where we're going to be a year from now, 2 years from now, 3 years from now.
And big shout out to Open Gear because they were our first ones.
Yes.
Yeah,
So extra round of applause for Open Gear. Yeah. We really appreciate all the support we've gotten from them throughout the years, and they continue to support us. So thank you very much, Open Gear. Any additional thoughts, comments?
Do we want to talk about kind of some of the events we've been through
this week? Yeah, absolutely.
Yeah.
So I'll introduce now Daniel Pelfrey. He's a senior network engineer at the Oak Ridge National Laboratory. Daniel, say a few words.
Well, it's a pleasure to be here. I was glad to have you all out at the lab the other day. Hope you all enjoyed the tour.
Yeah, so it was kind of like a last minute thing, but in like the 2 weeks leading up to the event and us getting here, Daniel was just like, we could have you out at ORNL for a tour, and we're like, oh, cool, that would be great. And so we started working on what we needed to do to get on the campus and do the tour. And we were working with their media point person, Katie. And she said, we'll be able to have you on the tour. It's not uncommon for us to have content creators come out here and shoot some stuff. But, I have to be with you at all times, and I'm going to tell you what you can and cannot shoot. And I'm thinking like, okay, well, we're probably just going to get to see the campus and like nothing really cool. We got to get into the data center where they have, the Frontier supercomputer, and they let us do an interview with Daniel standing right next to the cabinets and everything. And it was just absolutely incredible.
I don't think any of us understood the gravity of what we were going to get to see there.
Yeah.
It was funny that we would go through and we would ask, we would kind of assume that we wouldn't be able to film and take pictures of certain things. So we'd get in front of, for instance, Frontier. We weren't even in the room. We were in front of the big bay window, taking a look at it. And you all were so accommodating. We'd say, is it okay? Do you think we could get some shots, take some video? And the response was more often than not, oh, yeah, sure.
That's why you're here.
That's why you're here. So yeah, it was fantastic hospitality. Thank you.
You're quite welcome. The highlight of it was I didn't realize I had a hot mic when you heard me open the cabinet. Like, oh,
That was great.
Yeah, so he had gone around to the back of a cabinet because he was going to show us some of the networking of it, and I still had my earbuds in from the camera, and he was mic'd up, and then I heard him go, "Oh yeah,"
It was clean and ready to go.
yeah, because he wanted to check it out, make sure it all looked pretty and everything.
So throughout the course of KTech Connect, we've had several events. Starting Thursday night, we had a networking event at Print Shop Brewery, and a lot of people came out for that. We had a great time. None of us are from the area, so I'm from Vermont. Dan is a little bit local. He's just south of Nashville. Andy's from PA, Alex is out of North Carolina, and Dan is out of Nebraska. So we're not really all familiar with the Knoxville area. I'm sorry, Tim.
Close enough. I wish I had Dan's beard for.
Sorry. Tim's from Nebraska. We're not really all from the area. We had no clue like who we were meeting, who we were talking to, but it was really great to get to know some of the locals.
Yeah.
Andy and I met and a very ambitious young man named Zeb. He was 23. He was like an electrical engineer. He had his pilot's license, and every time he opened his mouth, we're like, "What? What?" So that it was just really cool to get to know some folks here in the community, and it just really impressed upon us like the mission of KTech and bringing people together locally, and that's how you socially network and find out what's going on around here. So we just think that the mission of KTech really aligns well with what we do with our community.
And then people had to watch me golf last night. I'd like to thank my old man for those skills.
The sensei.
Oh, yeah. Should we talk about that?
Yeah, do it.
So I go to swing and I stand and I'm holding my club and I'm pointing. And I actually learned that from my dad. And it's supposed to help you orient where you are. So Dan's standing right behind me and he doesn't know what the heck I'm doing. He thinks I'm like giving up a sacrifice to the gods of golf or something.
Please go
But
home.
please. Don't fall down. Don't fall down.
Yeah.
No, it was a great event as well. We got to every event that we got together, we got to meet new people and make new connections. It was a lot of fun.
Yeah, so Friday afternoon there was a lunch event at the Chop Steakhouse, right? Chop House. Chop House. I brought us to the wrong one, and then we scrambled across town.
There were 4 in this great city. Yeah.
We had a great talk from the director of AI at ORNL.
Yes. Yeah, very cool conversation.
Dr. Bagoli.
Yeah.
Yes,
I think
yes.
that's right.
Yep. So thankfully we got there late because when we sat down at the table, we sat with him, and we saw he was wearing the laboratory polo, and we're just like, oh, hey, cool. What do you do at the laboratory? He's like, well, I'm a... and we're like, oh, okay, all right.
Speaker, okay.
Yeah. So we had a great conversation with him about what his work and what he does, and he actually asked us some very thoughtful-provoking questions because he understands AI from how he works with it, and he didn't really quite understand how the enterprise might utilize AI. And so we shared with him some of the ways that we're aware of it, and he was very enlightened by that conversation. So
I love that because he was asking us all kinds of questions like what do you guys see? What do you think are some trends that are coming up? It's like this guy has a PhD.
It was very interactive.
Okay, yeah, you want to know our opinion? So that was cool.
Very cool.
And then, as Tim said, Friday evening we had a Talk Golf event, and all of us made ridiculous. I don't want to say the wrong thing, but we made
Fools of ourselves.
fools. There's the word. There's the word. Fools.
It's free entertainment.
AJ, in your defense, it's a terrible game. I mean, it really is. I love it, but it's a terrible.
It is. Let's see. Then Saturday morning, we had a breakfast event. Oh wait, that's today.
What year is it?
Yeah.
So this morning we had a breakfast event. That place was very cool. It was just a beautiful spot. So We had a wonderful breakfast as well, and even though we were supposed to be out of there by like 10:30, we just stayed, and the conversations kept going. We walked around the mall, got more coffee. It was a good time.
So I think to highlight what you just said there is this whole event has been nothing but awesome conversations with
Yeah.
the local community here, and then also some of our followers in Discord and whatnot that came from their different areas as well. So it's been awesome getting to connect with the locals here, because I was talking to Eric, and I'm pretty sure I kind of want to come back for more KTechs. So
Yeah.
I'm only about 3 hours away. So yeah.
Yeah, absolutely. And because this is KTech Connect and an Art of Network Engineering event, I don't want to not acknowledge that some of our fans came from very long ways away to come and see this event. And we just really appreciate y'all so much for flying and driving as far as you came from to spend time with us. When we talk to you and you say, oh yeah, I drove like 9 hours to be here, we're like, what?
Isn't that awesome?
Nick wins the prize. Right? 9 hours from Florida.
9 hours.
We-
yeah.
We love you all, but we are not that cool.
But honestly, that's the best part of this whole thing.
Yeah.
Like, we talked about COVID and the lockdown, and then we created this community, and it was all virtual, right? And then when we finally got last year in Asheville, we finally got to like meet these people. It's a surreal thing to meet people
Very.
online first, and then you're like, oh wait, I know you. You're this username guy, right? Like, no, I'm actually Andy. Hey, I'm Andy. So it's just been so amazing, and just even here, like people showing up, but that's the best part of it. Like before our podcast, I don't think I ever really met anybody outside of my job in tech.
Right.
I wasn't going to KTech events or my Chamber of Commerce. I wasn't included in any of those. So that's what this show's done for me, is it's opened up all these relationships with all these people. It's just been like so fantastic, and it's so neat to, like, I'm looking at them like, oh, there's Will, I know him, and Nick, and like these are the people in Open Gear, and so that's the best part of it for me, is just getting to connect with people and make friends. Because I wasn't doing that before we got together. The show started, and the community, was built. Like, I met a family member at the thing the other day I never knew before.
I know, that's
my
crazy.
cousin David. He's like, hey, we're cousins. I'm like, okay. But he starts to describe the fact. I'm like, oh wow, he's second cousin since like I met a new cousin here as a result of this show. So anyway, I just love the community tie. It's been so
This
amazing.
is way cooler than talking to a camera. So
Right? Yeah. I mean, we spent the first year and a half just talking to our computers, like doing the thing, but getting together in person and people showing up, it just means the world in the events, and it's just been so nice getting to spend all this time with folks. It's just the best part of it for me.
I will say, and I was talking to Alex about this earlier, that the only downside to doing stuff like this is that when we go home and start to record episodes again remotely through a webcam, it's like, man, this is not as much fun.
Tim asked me to send him a link. I'm using a green screen at my home office. He's like, hey, can you send me that link? So I texted to him last night, and I immediately got sad because I'm like, wow. In 24 hours, the next message I sent, he's not sitting right next to me anymore. Like, I'm going to have to wait a year to see him again.
Yeah. Hopefully not.
Don't make me cry, dog.
And then there was a lunch event, and now we're here. And
the brisket.
the brisket. The brisket.
It was so good.
I wasn't even hungry. I had 2 plates of food, 3 desserts.
Yeah.
Yeah.
I know. When we got out of the truck, we're just like, I'm not even that hungry. I don't think I'm going to eat that much. And we're sitting there like with a huge plate of food.
Yeah,
It was
Dan,
so
is the
good.
South heaven? Is that what it is?
That pecan pie, though.
About the closest thing we're
pecan
going to get,
pie,
huh?
Sweet tea.
Right?
Banana pudding.
Oh yeah, that was good. So in addition to the KTech events, we're content creators. So this is the only time that we get to be together is when we do stuff like this. So in our downtime, we were spending time creating additional content. We were recording additional podcast episodes in person. We actually had an opportunity to work on some sponsored content that we were videoing or shooting back at our Airbnb, and it's been a whirlwind few days. So if we sound a little sluggish, I'm sorry.
I'm so tired. Another thing I'm thinking of, my brain's starting to wake up a little bit. So beyond the community thing, like the opportunities, so we've talked before about, the people listening at home maybe, or, we've talked about like the value in like being a content creator, whether it's writing a blog or whatever, just to like start to get your name out there, make, an impression for jobs. I don't think Oak Ridge National Laboratory would have reached out to me without this show and be like, hey, why don't you come in and see the fastest supercomputer in the world, and we'll teach you all the problems we're solving. And do you want to learn about, what is it? Neutron bullets? Right? Like,
That's
I
not
stood next to a
scientific term,
nuclear
by the way.
reactor. Like, so there's just been so many opportunities in my career, in my personal life, in relationships, and in cool stuff like meeting Daniel and then the AI doctor and the just as a direct result of just a bunch of nerds that are like, you want to study? And
Well, I want to call that out. We were on the site where the Manhattan Project research was done. I mean,
crazy.
just crazy. And then everything that's happened since then, which we'll get into. But.
Speaking of which,
But
Hey, have you met Daniel?
But that happened because you asked us, hey, do you guys want to start a study group? So just, the power of community, like find your people.
Yeah. Yeah.
Whether you're trying to get in tech or whether you're this nerd that doesn't really talk to people, just find some people and spend some time. And like for us at least, magical, I know that's an overreach, but magical things have happened. Like I stood at a nuclear reactor yesterday. What?
But your content is impacting, right? Your content is impacting for other network engineers. I mean, I wish I would have ran into folks like you 30 years ago, right? Because there's a lot of folks out there. There's a huge benefit there. So you're all greatly appreciated.
well, thank you.
Thanks, Daniel. This is the
appreciate
community we wish existed when we were coming
Right.
up, studying, trying to. I've said it a million times, but when I was studying for my CCNA, trying to get into tech, my community were my fellow cable guys who told me I was wasting my time, money, and nothing was ever going to come of it. But now we have a Discord group with almost 6,000 people, and everybody's patting themselves on the back, saying "attaboy" if you fail, or like it's okay. The power of that has just been really amazing.
Right.
I mean, people reach out to us all the time, like you've changed my life, or you helped me, or hey, I finally got the thing, and
Yeah.
so
It's crazy.
yep.
Enough about us.
Daniel.
Kick us off.
So we're here to record an episode with you. We are going to interview Daniel here and learn a little bit more about what he does at the Oak Ridge National Laboratory.
So, Daniel, I want to kick this off. You talk to us a lot about supercomputing and high performance computing. So, for us and our audience benefit, can you really define what high performance computing is and what makes it different from a traditional enterprise data center computing environment?
Okay, that's a good question. Your typical data center environment is commodity hardware, right? You're basically like VMware clusters or using a small group of systems to do something for the enterprise. Typically, that you really don't care a whole lot about latency. The applications might be in the same data center, it might be around the world. It's kind of a difference of scale. Because when you have a large supercomputer, basically, especially what is called a leadership class facility, that's basically designed, it's basically massively parallel systems acting as one. And so let's go back to the original part. When you're operating on a single computer, you might only be doing a single job, right? The whole purpose of these leadership computing facilities and large supercomputers is to take advantage of the whole system. So what you can normally solve with one system, this system can do it, chunk it out in parallel, and get you the result back much, much faster. And this, when you're doing, I don't pretend to be a scientist or understand all the mathematics behind it, by any stretch of the imagination.
What do you want to know?
Nice.
Neutron bullets.
So before we dive too much more into the supercomputing environment, I just want to kind of set the stage. Daniel, how long have you been a network engineer?
Almost 30 years.
And have you always worked in the scientific or collegiate studies environment, or have you spent other time in other aspects of network engineering?
So the first half of my career was primarily, so I started in a mom and pop ISP back in 1995. I was there from customer number 0 to around 75,000. We were the first, I guess I have a habit of being in like the first in something, or something that's breaking records, because we were the first ISP in Southern Ohio, and we basically brought internet to that region. And it was just keeping up with the growth, the servers. I mean, I had my hands in everything: servers, network, customer service, billing. We were a very tight-knit group, and we kept everything running. I mean, it was a very much my goodness, yeah, we were compared to other shops along the way, and we acquired many other many other ISPs along the way. Ultimately, our company was, we sold to a company called OneMain.com, and it was a nationwide ISP. That's how I came to be in Knoxville. There was an awesome network engineering team here in Knoxville, because they were U.S. Internet, and that's where it's amazing when you jump in scale, because I mean it's always drinking from the fire hydrant the entire time, and keeping up with the growth, keeping up with all the challenges, learning it as I was going. Because when I was in college, we were learning IPX, SPX programming, right? And at the same time, it's like, here I am building an ISP, and it's like,
Yeah.
where, there were no such thing as classes, and the books were very few and far between. So it was constantly researching as I was doing it.
So I want to push on that scale a little bit. When you talk about working for ISPs and purchasing and integrating more ISPs, that scale jumps. Do you have any experience in automation to be able to adapt to that scale?
Back then, I mean, it was a lot of, so when we were acquiring the other companies, it was a matter of doing our due diligence of figuring out how did they have their passwords, how did they keep all their billing information. That was a lot of spreadsheets and databases. The configurations at that time there wasn't really automation in that sense. I don't recall using Expect really until like the late 90s, I think. And even then, it was a lot of the gear had it wasn't some of it was your typical CLI, some of it was very text-based menus. Where you really some of the gear, it was almost impossible to script via Expect.
I got a question. Sure. You said something I thought sounded cool, multiple systems acting as one, and I guess that ties into the latency requirements. Is it because everything is communicating across the system all the time?
Sure.
Latency is critical?
Well, not just latency, but also the bandwidth between the systems. I mean, everything has equal cost bandwidth to just about everything, plus the file system. So, I mean, your typical Ethernet connection is 1 to 2 microseconds. Which, if you go down, like if you were looking at the
End to end that we're talking about, like one on the wire or the other?
No,
Okay.
just one hop to the other. And if you go through a firewall or something like that, it's probably going to be somewhere between 3 to 10 microseconds. So if you think about your time going switch to switch, to hit the SVI, to hit every time you hit a hop, you're adding latency, right? So really, it's the sum of the end to end of all those combined is really what you're seeing. Now, when you start talking about high-speed interconnects, like what we saw at work the other day, you're looking at something that is in the 300 nanosecond range. And then if you look at something like InfiniBand, that is in the, I think it's around 100, 150 nanoseconds. So it depends on your application, because think about the speed of your memory. I mean, you're literally, how much time it takes to actually send those bits to your memory, to your CPU. I mean, you're practically bottlenecked by your processor and memory when you think about that.
And high level, just to pop up a level for a second before we get to the next question, can you tell people, what is the purpose of a supercomputer? What is a supercomputer? Like, I know we talk about exaflops and speed and all that, but I love the time machine kind of metaphor that was given. So what benefits does a supercomputer give humankind?
So let's go to the origin of some of this stuff. The Manhattan Project, mathematics. You're basically modeling, some of the original computers were designed in the Second World War. They were basically doing ballistics, doing calculations to how to put warheads or drop bombs. That's where a lot of that stuff originated. They basically were able to do simulations to figure out, like for atomic weapons, right? I mean, they were able to figure out, to be able to look at this. But there's peaceful applications to this. I mean, it's one of the things I love about Oak Ridge National Lab is, although it's rooted in the Manhattan Project, that was a sword. That sword has basically been reforged into a very useful purpose. Now, let's talk about those peaceful purposes. Energy, research, with like batteries, solar power, more efficient engines. Let's talk about medical research. There was stuff about COVID-19. There has been stuff, it's been various genetic research. Trying to think of all the other things off the top of my head. It's a little overwhelming, but the impact benefits industry, it benefits this country, and it really benefits the world.
So if you put the smartest people on the planet in a room working on a problem, it might take them 5 or 10 years to do something that the supercomputer could do how quick? Days, a week?
It depends on the nature of the problem they're trying to solve. I mean, some things are, the other example I forgot to mention was weather modeling, right? That's something that's also was helped drive this technology has improved where we have better forecasting. So I mean, all kinds of peaceful. But back to your question. it's I'm trying to think of the best way to explain that.
I thought Katie had
Yeah.
said, like, when we were talking to her, like, something that would have taken 10 years could take, like, a week.
It could.
So shrinking that time horizon of solving a problem and pushing,
Well,
humankind
I
forward.
want to bring up, what we were talking about the other day with the AI, that, they were involved very early on with COVID-19 research, and as we're now on the other side of the pandemic, if they hadn't had access to that supercomputer back then, we might still all be locked up in our houses. And just like, how incredible is that?
Yeah, it's potential. That's way over my head, but
Yeah, I mean, it had to have been very exciting because the picture that was painted to us was that the research lab was contacted in like February of 2020 and said, hey, we think we have something here. We need to start doing this research. And you and team were able to give access to the supercomputer and were able to start doing those calculations and relatively quickly be able to start pointing scientists in the right direction to find out how to attack this virus.
Yeah, I think
mean,
Dr.
that's
Mazzoli
incredible.
said like 4 weeks.
Yeah,
4 weeks.
yeah,
for the
we're not
supercomputer.
talking months. We're talking
Yeah,
a number of
and
weeks.
they had
yeah.
viable attack options for areas that
Yeah.
they could look at for developing therapies.
You can't get more close to a real world application that's helping people than that.
Yeah.
that's also a testament to the lab's people, that they have so many people who specialize in so many different things. I mean, there's people of every branch of physics, chemistry, biological, and they all help the users write their code to take advantage of these systems. So that's
Well, another tie-in, I think of, what is it, neutron bullets? Is it neutrons?
Yeah.
So when we went over to the other side, to the nuclear side,
Right.
that gentleman was telling us that they can pass a neutron beam through a material. So let's say, I don't know, your job is getting things to space, and you want to see if maybe a weld you're doing on a piece of metal, can it withstand the rigors of space and reentry and all that stuff? So he passes neutron beams through this material, somehow gets results magically.
Takes pictures.
Those results, I think, get fed to the supercomputer, and then they can do the math to say how long this material or weld may last through all the rigors of space. And again, it's more, if you're putting something in space, spending all that money, maybe lives are on the line, all this supercomputing power to be able to extrapolate all that data and keep us safe in journeys, I thought was a pretty impressive application, right?
Yeah, it definitely was. I
Yeah.
mean, it kind of goes back to what they were talking about, it being a time machine, right? I mean, when you're modeling something and looking at how will this hold up 5-10 years from now, right? I mean, same thing could be with forecasting, right? Or with other, let's say let's say you're doing what was it, the GE with the turbine designs,
Yeah.
right? Being able to figure out how to efficiently place stuff. So
Daniel, I want to take a step back, and as a network engineer, I'm wondering if I could throw a two-part question at you.
okay.
For our audience, can you draw some parallels between your previous network engineering experience and a supercomputer? Like, are we still talking about layer 2, layer 3, spanning trees? Is that still a concern? And then the next part is, what are some challenges that you face working on that network that maybe other network engineers would never conceptually have thought of?
Okay. Well, all the fundamentals still apply, right? I mean, you're always going to have spanning tree, basic routing, basic switching. That's whether you're enterprise or whether you're a supercomputing facility. They all have, they use some, it's the same commodity hardware. I mean, the only difference is if you're doing a very high-speed, low-latency interconnect, that's going to be more specialized hardware. The challenges, goodness, that's where it gets interesting. You'll see. So it's a combination, right? There's anytime you have anything that is talking fast to slow, or anything that could be a bunch of systems talking to a single system. That concept is called microbursting. And you'll look at your graphs and you'll say, wow, I don't see, it's flat, there's nothing there. But you start looking it out down at the time, if you time slice that down into the millisecond range, still nothing. You get down to the microsecond range. Here we go. For 10 microseconds, this link was saturated. And that's where your buffers come in, right?
So what are you using to track all that?
There's tools for that. Different vendors have different tools. So some vendors will allow you to basically say, at this instant in time, X number of packets were dropped or frames were dropped. So
Yeah, 'cause
that
that's
greatly
not
depends
like
on
a
the tool.
That's not a common thing that you see in like the enterprise, right? Like nobody's going down to millisecond drops and like seeing stuff like that. So that's,
But, I mean, we still, even enterprise, we still cared about drop packets, right?
Yeah.
You wanted to figure out, but you might be scratching your head, but it's the scale. The other challenges that we face is the sheer number of systems. I mean, in my original job, I think our original data center was probably in at /24. That's fairly small. I mean, it wasn't, and that was only a couple dozen systems, right? I mean, once I went to Earthlink and saw a really larger ISP, that was very drastically different in scale. Goodness, maybe it was many of those, right? I mean, it wasn't something ground shaking. But what we run into, I mean, we might have 10,000. So we might have one system that has 10,000 nodes. Well, what happens when those? So in reality, is those 10,000 nodes might have two different network connections. Now that's 20,000 devices coming on the network at the same time.
Yeah, like what are your MAC table sizes and ARP tables and stuff like that?
So that, I mean, keep in mind we're using the same commodity hardware, so we have to be very strategic in our network designs. I mean, it's having a hierarchy is always a good best practice, right? I mean, you want to have your demarcation from your layer 3 to layer 2 to basically say where your routing is, where your switching is, right? So the most common example might be your spines for your routing layer, and your leafs basically going to be your layer 2. Problem is, if your switches can only hold 32,000 MAC addresses and you've got multiple systems with this sheer number, and keep in mind, even if your MAC address table could handle it, you have to think about your ARP entries, you have to think about where you put your SVIs, you have to think about your DHCP traffic. There's a lot of little things that you have to think about. And also, do you have anything going fast to slow? If you have let's say if you had something going 100 gigabit talking to a 10 gigabit host, and you have lots of those, that 10 gigabit host might say,
You have to look for your bottlenecks.
You do. You have to know the weaknesses in your network, every single weakness. And when we plan stuff out, I mean, we look at every single aspect, including how big is it, how much space do we have? Because space is a premium. Is the airflow correct? You got to make sure all the little things are perfect, even down to the power cords.
So it sounds like requirements gathering is pretty paramount to this. Is there, when you're talking about speeds and feeds for designing networking for a hypercomputing environment, is there a percent, you make your design, and is there a percentage of growth that you try to allow for, or how do you, because it doesn't sound like things necessarily move slow. It almost seems like you need to be able to potentially change or modify your design on a dime. So how do you keep it like that?
So I keep a framework where I can keep all the core stuff that everything is going to depend on. So we keep that for our core infrastructure, and that's basically your NFS, DNS, LDAP, syslog, NTP, all the core services that everything depends on. We have a modular design such that as we bring in these new systems, we will basically carry that via layer 3, where there's no way that we would extend a large network with, let's say, like a /16. We wouldn't carry that up to our load balancers or to your hypervisors, because that would just, the broadcast traffic and the amount of nodes could cause issues. From a scalability, that's not possible. So by isolating that stuff at layer 3, now you have a scalable solution to accommodate that. And then it's really a matter of function of doing capacity planning to make sure our uplinks correctly sized. Oh, we need to add more uplinks. Easy, add more links. So that's how we do the planning, and it's always, I mean, it's humbling to think about when it just seems like yesterday when we were gigabit Ethernet, right? And then then 10 gigabit, and then 40 and 100 gigabit. We're in the process of upgrading our internal network to 400 gigabit right now, and 800 gigabit is out already, right? So it's like it's a constant, just like the ISP days, right? You're just chugging along and keeping up with the technology.
I was just thinking of the poor TAC engineer who receives your calls.
So you know what?
Hey, they had 100,000 systems come up with instantly, and your switch couldn't handle it.
Typically TAC loves us, right? We basically try to do their job for them. So like Chris Hart, when you'll talk with him, we are their perfect customer. We like to We'll have all the debugging done. I mean, if it's a power supply, we've like, yeah, we swapped the power supply. We've already did all this. Just give us the RMA, right?
I forgot. These are the smartest people in the world. You guys aren't like, we don't know what's happening. Please help us. Yeah.
No, we've,
It's
So-
free stress testing too,
Right.
right? Like,
yeah, we do help. I mean, the thing is, no vendor is bug-free. They're all going to have their problems, and every one of them has been phenomenal in helping fix those.
So talking a little bit more on the design, is there like a typical architect or a gold standard for you? We've got spine leaf is the new hotness. Are you taking advantage of that, or why are you laughing?
The hotness is funny.
Yeah, or is it like a 3-tier architecture? What does it kind of look like? Is it a mix of both? Or
So today, it is a mix of both, right? So we had a typical 3-tier design because that makes changing out gear really easy.
Yeah.
I can replace my cores. No one will even notice. No one will notice it, right? If you start changing out stuff where you have SVIs and you're taking advantage of some technology like virtual port channeling or MLAG, now you're going to take an outage. So those are the ones where we typically, if we're going to bring up some type of new distribution that would basically be carrying layer 3 to layer 2 demarcation point, we'll bring in another pair of those and then start, test it out, then systematically migrate stuff over, rinse, repeat.
So in this design, you just brought up a good point of understanding where those points of lack of redundancy are when you're going to do these upgrades. So I consider that a caveat and understanding those caveats. So I'm continually drawing parallels between typical enterprise data centers and high performance computing environments. So let's continue down some of those caveats. On the enterprise side, we always know when we purchase gear and install it that there's a certain level of oversubscription across all ports on a switch, and you have to decide how much you care about that and how big of a deal that is to you. How big of a caveat is oversubscription in an HPC environment?
So you're always going to, we try to avoid it whenever possible, but ultimately some things have to be oversubscribed. Some services, it depends on the service, right? We affectionately call it building airplanes in the sky.
Explain that. That's an interesting concept.
I mean, we rarely shut down. We rarely take any type of downtime, right? So when I was talking about replacing the cores, no one would notice a beat, right? And whenever we do let's say that we're in the process of migrating over to a new pair of distribution where, we could be like another layer of spines, for example. We would basically, schedule a downtime, advertised a few minutes, okay, the cutover went great. Verify your routes, verify things are good. Okay, let's do it again.
Okay.
We don't really, very rarely do we actually shut down except in cases where, hey, we've got to swap. Now, like if you're moving firewalls, you're going to lose your state, right? That's where you really
Big
have
issue.
to take a hit, right? But there's no way around that.
I will say though, I'm no government official and I am not one to judge, but building an airplane in the sky sounds like an OSHA violation.
Yeah, I got to tell you, if I'm on the way home tomorrow and I see a mechanic on the wing trying to swap out the end,
Living the dream. Right?
Yeah.
and that's why I don't fly.
So continuing on some of those caveats, some of the other things I was thinking of that we tend to have to think about in enterprise environments are things like maximum transmission unit, MTU across your switches. Dan brought up understanding how many MAC and ARP entries your devices can handle, as well as do you ever have to think about where it might make more sense to have fixed switches versus chassis switches? I know I just threw like 14 things at you. So.
You did. Yeah, so so we'll start with the MTU, right? MTU is dear to our heart. Everything's jumbo, right? So if you have, for those, your standard MTU is 1,500. For those, our standard MTU is 9,000. You have to be careful about if you have fast to slow systems, like a 9,000 MTU system talking to a 1,500 byte MTU system. If PAF MTU detection is not working, someone's going to have a very bad day. Yeah. You'll basically end up with TCP spiraling to its death. So your second question about chassis versus fixed switches, that really depends on space. That depends on what's available. That depends on the needs, right? That's going to vary from system to system. Sometimes it makes sense to have a miniature aggregation layer where everything would connect to something before it gets backhauled to our main network. So in those instances, a top-of-rack switch might be perfect. But there may be another instance where we need a large chassis switch where everything can be wired in so it's a single hop away. If you have a lot of cabling, you'll have, it depends on the need, right? So ideally, I mean, I'm fine with either. I mean, it's a lot easier to change out. I mean, I love swapping out blades. I would prefer to do that as opposed to having something forklifted. So, but reality is if you have enough, if you have things spread out, it's not going to be too painful.
Well, and we actually got to see that live in action. It wasn't on the network side, but on the compute side, we actually happened to be there when the team was there swapping out compute blades, and that was another level for me. I've never seen that kind of thing happen in an environment like that, where they're actually using a lift to help get blades in and out.
It's a fancy doohickey.
It was a fancy doohickey. Yeah, that was the technical term. Thank you, Dan.
I don't know how heavy those things are, but I imagine, I mean, if the switches on the back end side of that thing were, when I looked at the data sheet, I think it was around 60, 70 pounds.
Oh, wow.
So with the center of gravity of some of these things, you would want to have something to assist you there, especially when you're doing it by yourself for safety.
Yeah, especially when you're doing like the top one
Yeah.
too. Yeah, like you
Yeah.
saw the other day.
Yeah, because those cabinets are tall.
Yeah, they are. Yeah, they're not your average data center cabinet, that's for sure.
I struggle with the stuff that's at the top of some of the if it's like 8 foot tall, like I'm gonna.
And you're a tall guy.
Yeah.
So we have to, I say, I'm being the collective we, this is all you, Daniel. But when you're when you're acquiring these requirements from different team members, I'm trying to understand who you're asking these questions to, because it's not just a network team within the HPC lab. You're working, you have to work with a bunch of different people. So when you're trying to gather these requirements and understand what you have to support in these environments, what teams are you working with? Who are you asking these questions to?
So there's an analogy that a prosecutor can get a conviction on a guilty person, and a great prosecutor can get a conviction on an innocent person. I like to say on the networking side, a good network engineer can fix a networking problem. A great network engineer can help solve and help a systems admin fix and design networking. We're interrelated, right? So it's a matter of, so it's the team basically gathering requirements, but it's also our knowledge of helping troubleshoot systems, helping drive the right questions to ask, because most server admins are not going to know a whole lot about networking, so they do depend on us, right? And we try to, it's a balancing act between what we know and what we don't know, and going and asking those pointed questions to make sure that we have the right design, that we have the right hardware, that we understand what their needs are, just in case something changes. So I guess let's say, for example, management systems. You want to make sure that things are, you want to be mindful of where bottlenecks are. So let's say you're bringing up a 700 node cluster, and they're all talking to.
No big deal, by the way.
Right.
That's Tuesday for me.
Yeah, just another Tuesday.
Yeah. So they're talking to a single management server. Well, what does that, if we don't design the pathing correctly, where are the bottlenecks there, right? Because let's say that this only was on two different cabinets and just two different switches. If it's having to traverse up the network and back down, that might make sense to have an aggregation point there to keep everything equal cost multipath, so that would work. So it's a matter of getting, those are the types of requirements, and again, it's a combination of the team's experience, because several of us have mix and match of systems and networking, because that kind of goes back to my ISP days.
So I want to touch on that, because
Okay.
we always talk about the people and the value that people bring. I would say that in some, not all organizations, you have silos in different. So you have systems teams that are narrow focused on compute and storage. You have network teams that can be narrow focused on networking. And it sounds like we got to see that there are different teams with very different specialties. Yeah. But you don't silo off people. You're there collaborating. Can you kind of touch on that more and explain what that looks like on a day-to-day?
Sure. So I mean, some of the HPC admins really great with networking. I mean, they know it inside and out, right? It's going to be the specialization. There is no grenade lobbing, right? I mean, we will basically, even if we know that it's not our issue, we will help. Hey, okay, I know that it's not this. I'm pretty sure that it's this. We're going to go to this person to get their help, right? So there's always that collaboration. There is no grenade lobbing.
Sure. Sorry.
Sure.
Do they always blame the network though?
Oh yeah, here's the thing. I always blame the network. Right? I will rule it. We will all rule out that it's not us before we contact somebody, right? So we'll err on the side of caution. I mean, it happens, right?
Is there any secret sauce to building a collaborative culture? Because many production environment, thank you. Many production environments I've worked in are very siloed. You know, application owners want to open up a new subnet, put in a request, it'll be 45 days. You want to open up a firewall rule, put in a request, it'll be 30 days. So you guys are so, you stole my question. I didn't get any sense of silos. You're all very collaborative. Is it because the type of work you're doing is just more important than pointing fingers?
So we do have processes, right? We do have ticketing systems, and we do have formal processes. But it's a 5-minute job. You know, hey, it's we need to make sure we document that we understand what you need, and that we understand the bigger picture here. Sure, no problem. It's done, right? On to the next ticket, right? So it's a combination of that. Someone might walk up and say, hey, I've got a problem with, I'm trying to move data from this point to this point, and it's a matter of systematically figuring out where the problem is.
You just reminded me. I was gushing over the brilliant people we met there. And I'm like, wow, those people are just so smart. It must be so intimidating. And you had a great comeback to me. You're like, well, they might be the most brilliant math mind in the world, but when they come to me and say, I'm trying to push 1.75 terabytes through the network and it's not working, can you help me? You're like, yes, I can. Yeah, well, that's my jam.
That's we all have our specialty, right? And that's one of the beauties of the lab. We have people who specialize in networking, in file systems, in computing, and security, and we all work together. And it's many of us also have wore many other hats, so we understand those. I mean, I guess what's that called? Unicorns. I mean, even in a past life, when I worked at an ISP, they thought I can think of a radius problem. They thought it was the network, and we systematically worked all the way back until we found that someone was trying to zip up I think it's like a 2 terabyte file, and it was killing the file system, which is killing the radius server. So, wasn't the network.
It was DNS.
Well,
It's always DNS. So continuing that, you just mentioned segmentation, and I always, when I'm thinking of any facet of networking, I always think of it, or try to think of it with security in mind.
Yep.
And you mentioned earlier how sometimes you have to deal with firewall upgrades. So how important is security and segmentation in your environments?
Absolutely critical. Layers. And we have a, let's see, I'm not sure if I'm allowed to.
Yeah, I just got a text from Katie. She said,
So here's what we'll say. Security and segmentation. In computing environments.
Check. Yeah. So we have moderate.
Wait, is compliance that easy?
No,
Say check.
So we have open stuff, we have moderate stuff. It all depends upon how you authenticate, whether you're using two-form factor or a hard-coded password. Those two types of systems cannot be in the same VLAN, right? So that's if you wanted a high-level demarcation point, I think that answers your question. But yeah, there's definitely, without going into too specifics, there is definitely security in depth and ways to troubleshoot that.
The first answer that came across his mind is none of your damn business.
Yeah.
So it's a very nice recovery.
No.
It's like ogres and onions. They have layers, right?
And pelts, they're layers too, just so you know.
Nice.
So I was watching a YouTube video you sent to me of a presentation you did earlier this year.
Okay.
And where this question is going is kind of understanding how the outside users of your supercomputing environments, how they leverage and get data into you. You had mentioned earlier this year that you were migrating to multiple 400 gigabit per second internet circuits.
That's correct.
Why is that level of bandwidth important to your business?
Well, today we have 100 gigabit links, and sometimes they get saturated. So we have to be mindful of, I mean, with a 100 gigabit link, you can move a petabyte a day, right? So we have multiple 100 gigabit connections, and it's time, right? So we're in the process of that's getting fiber. As you noticed from the drive, it's a bit off the beaten path. So it's a challenge getting fiber out there, right? So as soon as that fiber gets there, we're very excited to get that in there.
So when you say multiple gigabit links, is that to the nodes or is that uplinks?
Those are uplinks to our internet connection, ESNet.
Oh, internet.
Those
Yeah,
are internet.
that's internet.
That's
Dan.
internet.
Oh, wow.
Yeah.
So
Okay.
that's 100 gigabit through our WAN.
Yeah, nice.
And just so I can frame this up and understand, the purpose of those internet links are for your users to be able to get data and applications into the supercomputer to be able to leverage that level of computing. Is that correct?
Absolutely. So so we have different types of nodes, and I think this is where your question is going. So some of the nodes are meant to be just log in, right? So user logs in, they will submit their jobs, they'll interact with the systems. It's kind of like it's a gateway or hop in to where we have so many nodes, right? We can't put enough public IP space on every single compute. V6, sure, but V4, not so much. We don't even have that kind of IP space for even public for the lab. But the data transfer nodes. So a data transfer node basically connects to our parallel file system. So that parallel file system is what the computes talk to. So when the computes run, they checkpoint their jobs. They save it every so often, as I mentioned earlier. So if you lose power or something, they won't lose their work. It would suck to have a 30-day job and you got to start over again. No, that would be expensive, right? So the checkpointing is critical. But their job. So let's say that they have data here. They would basically copy that data, use the data transfer nodes across the Ethernet to the WAN, out to the internet, to wherever they're taking it. Sometimes the data set will be really tiny coming in and be huge going out, or huge coming in and tiny going out. It depends on the flow.
So you're saying users, and who uses this?
So the users. So there's different users, right? I mean, they're not just at the lab. I mean, some of the users are around the world. So there's different program allocations. And based off the science merit, I'm trying to remember exactly how Katie had worded that, but she did an elegant job.
Yeah, she's going to chime in here pretty quick.
Yes. So basically it's based off the merit, right? So these different committees will look at this application, and they also have to meet the criteria of the use of the full system, right? But they also have to make sure that the work is public. I mean, that will be published and that DOE is given credit for that.
Mm-hmm. But are these can we not specifically name drop, but what type of institutions are using this?
It will be all kinds. I mean, it will be R&D, it will be industry, it will be academia. It's going to be all kinds of industries, not just, could be, that would be, it would depend on just about every industry imaginable that would be using supercomputing resources would potentially be a user of this.
Gotcha. Okay. And going back to migrating from 100 gig to 400 gig links, you mentioned the importance earlier of capacity planning. Mm-hmm. So you had to get to a point where you found out that in the future that wasn't going to be enough and you were going to have to migrate to 400 gig links. How do you monitor that? Is that something you're actively monitoring? You have systems that are doing that for you and alarms on thresholds? What does that look like?
So, I wouldn't want to get woke up at 3 a.m. of that something had a 5-second spike, right? But we do have tools actively telling us this information, how long it occurred, when it occurred. We also take steps to mitigate it to make sure we take advantage of both paths. So we try to do multipath. Technically, incoming is a little harder because of BGP. Basically, we don't really have our data transfer nodes being announced out of two different, in theory, we could say, hey, we'll take this subnet, announce it here, this subnet, announce it here, and going back in, but that's not really our big problem. The data going out is typically our big problem. So with our multi-100 gigabits out, we will throttle those down by multiple 40 gig connections to help chunk that down a little bit so that we're not killing the 100 gig path when the large data transfers.
Interesting.
So it's kind of our own way of keeping things strategically bottlenecked so that we don't shoot ourselves in the foot.
So you mentioned IPv4 and IPv6, so I have to bring it up.
Oh, no, yeah.
Are you guys like transitioning to IPv6? Is there like talks around that? Is there?
So we
Other
have
issues?
we have V6 routing. We've actually set it up. Getting V6 is very slow moving, right? I mean, it
been
is. I
coming
mean,
for 30 years.
It has, right? I mean, the routing is there. It's fairly from our perspective, it's easy. On the system side, not so much because you have so many things to think about. I honestly don't know where that is off the top of my head, but V6 is. I love playing with it. Really, it's fun.
Right.
I just can't remember it. I cannot remember a V6 address to see if my life depended on it.
Yeah.
V4? Oh yeah, I can tell you my first DNS server from 30 years ago.
Yeah, so when I was in school in like 2010, my professors were saying like you got to learn V6 because we're running out of V4, and here it is, 2023.
What is that Andy always says?
Yeah.
Nat for life, baby.
Nat is your friend, right? I mean, it makes sense, right? Except when you need the true end-to-end connections, right? I mean, that's really.
I also got to, so we have Alex from Cables to Clouds. I also got to call out Chris Miles. He says that NAT is one of the best security products ever.
Yeah.
Security through obscurity,
He
right?
says it's never absent technology. Yeah.
That's great. Daniel, one of our focuses throughout the entire life of the podcast has always been, mental health. IT is a very stressful job, and there's got to be some sort of balance. So outside of your day-to-day work, what are some things that you do to help stay sane through all of this?
So work is very good about encouraging work-life balance. If someone sees me working longer hours, I'm going to get told, "Hey, you're working too much. Throttle it down a little bit."
Nice.
Everybody I work with, they're friends. They're not just colleagues, they're friends, right? And we all look out for each other. So there's that aspect. But otherwise, I mean, outside of work, family time, exercise, hiking, getting some, enjoying time, having fun with the family, games, unwinding, reading. Making sure that when I take vacation and actually do something fun, right? Not just sit around and go have fun and unwind. That's the key thing. I mean, you're right. IT is extremely stressful. I mean, looking back over the years, I mean, we all know what burnout feels like, right? And it's 99 times out of 100, it's self-induced.
Yeah,
It's a
and
matter.
it sneaks up on you.
It does.
Yeah.
It does. I mean,
If you don't monitor it, yeah.
Yeah.
And Daniel, you and I had a conversation yesterday. One of the coolest things I saw when we were at the tour was we would walk down hallways and in common areas, and there were different groups of people that were having conversations. And you told me a story of kind of how that started. Can you bring that up to me? You said that there was a game that people were playing, that they would go out. Pokemon Go was a big thing.
Yeah.
And people would go out, they'd have these 5-minute raids that they'd go out and find these Pokemon. And that's how people would start coming together and find those interdisciplinary relationships. And they'd start talking about life and work and other things. And it was just really cool to see because we've talked about, Andy brought up the silos earlier, and we don't always come together, but we saw that around every corner at the lab the other day.
Yeah, it's good. I mean, we have a great common area for breaks and, between the coffee shop and all the other discussions, right? I mean, walking around the pond and everybody, it's, sometimes people will, what do you have in common, right? I mean, that's so
Yeah, it smells great in there, by the way. All the coffee.
Oh, yeah. Oh, yeah.
plan
Right
that
as you
well.
open that door, it's just
Yeah, it just hits you.
Yeah, they make great coffee there. But no, it's it's great to see people just having something in common, even if it's something as simple as a quick 3-minute break and figuring out, hey, what do you do? What parts do you work on? And it's interesting. It really is.
Daniel, we always try to keep newcomers to the field, people either looking to break in, trying to break in, starting their journey in mind when we have conversations with seasoned pros like yourself. So one thing that I'm wondering is, you've been in tech for 30 years. You've probably seen it all. You've had some really cool jobs. Knowing what you know now through all that experience, you have any advice for the newcomer, or put another way, you know, what would you tell young 20-year-old Daniel Pelfrey with stars in his eyes just getting into tech? Is there anything you'd change? I mean, just all that, you know, those three questions. What would you do anything differently in your career?
So that's a very good question. I've thought about that a lot, right? So I don't regret. And the thing is, I have always kind of had the mindset of trying to understand as much as I can, right? And I can put so much in here, something's going to come out here, right? I mean, that's just the nature of the beast. So I've always been fascinated with science and always fascinated with computing, right? I mean, I started playing with computers when I was, practically, I was barely 10 years old, right? And but having a passion for learning, having a passion to understand how deep the rabbit hole goes, that pays off. Follow your passion. Find joy in what you do. I mean, that's the bottom line there. I've seen people go in careers for the wrong reason, thinking money, and they have no idea of the pressure, what to expect. You have to get joy. You have to enjoy what you do, right? But with that being said, I mean, a lot of people will say, and I know this is somewhat of there's a holy war on this, right, between tech and education. But having that foundation material, right? If you have a foundation, I mean, certifications are great, but if you go and pick up a book like on computer networking or follow it from an open source perspective, and you look at it from a system administration perspective, and then you look at it from a file system perspective. I think I shared some links with you all the other day about what I call foundation material. Also, electronics, right? When I look at routers and switches, from my background in electrical engineering and computer engineering, it's like I don't see a black box of death. It's not a mystery box, right? I mean, you're literally chasing ones and zeros in a processor. I mean, it's so having an understanding of what's going on, whether it's the processor, ASICs, having a good understanding of the big picture. I mean, you still have to have specialization, but having that broad depth will help you understand the big picture to figure out when you start diving down to these rabbit holes, how does this stuff interact? Because it gives you, I think it gives you a better appreciation for what's going on under the hood.
I agree, and one of the things we talk about is when we talk going broad or having specialization is it's great to have a specialization, but just like you said, to be able to go broad, because we all talk about, Andy, you talked about breaking into technology, and a big part of that is the job interview process. And there's always those horror stories if you go into those job interviews and it's just a bunch of stump the chump questions. But I think what's really important is not necessarily knowing the direct answers and having that rote memorization, but if you know where to go to find those answers, that's really key, and that just means having that broad knowledge of adjacent technologies.
So I would tell past Daniel, embrace more mentors. Don't go out on your own and waterboard yourself until you figure it out. It's a path of pain potentially.
Sure.
So it's having good mentors who could help guide you to say, hey, you're strong here, you're weak here. Don't worry about this so much. That type of guiding hand I've had it off and on throughout my career. And even from my first job, I mean, my first job was shelving books at a library, and here I am in high school, and my boss, she was 73 years old, running laps in the library, and she encouraged me, like she was always encouraging me to read, because she knew me from the time that I was, I'd been going there from the time that I could read, right? So that type of encouragement, having people in your life to help encourage you to do better, that's something you always want to surround yourself by people who you can learn from. But the mentorship it is absolutely key.
We've got to bring that Dewey Decimal System back.
All right. At this time, we have a wireless mic available here in the auditorium, and also there's a chat feature, I believe, in the live stream. So if you have any questions for Daniel or ourselves, we welcome you to come up and ask. Don't all jump up at once, though.
Are we out of time already? That went by fast.
Want to walk up to the mic so we can hear you? There's a microphone up there. Thank you.
Just bear in mind, don't ask too direct questions about what goes on at ORNL. There's only so much that Daniel can
It's
talk
not
about.
going to be direct. It's an honor to be here, listen to you. I think at one time was able to visit the facility. I enjoyed the area. And my question to you is, I heard you were talking about the bottlenecks in the communications between nodes. But at the same time, I can understand that the power of that big animal is all the power on those processors. So where do you see group moving forward, where the actual bottlenecks is going to be either on increasing more the power of those processors or allowing or having less latency or more bandwidth between them?
Yeah, that's a very good question. I'm going to say this as me as a person, not me as a I couldn't even be as a employee. I could not even begin to fathom. I couldn't speculate there.
Okay.
But if I'm wearing the hat that if I had to take a wild guess, that's a tough one, right? I mean, Moore's law is. I mean, here's the thing: everything is always getting smaller, faster, cheaper. And everything is an arms race, right? I mean, even with networking today, there's been an arms race between InfiniBand, Ethernet, and it's kind of back and forth. I mean, right now it's or other types of fabrics. You have the same thing with your processors. The same thing with where you're talking Intel, AMD, and different types of GPUs. They're always going to be smaller. They're always going to be using less power, especially more efficiency. That's an absolute must. I really think that the network will probably be the bottleneck at some point. I mean, it always will be, right? I mean, it's, when you're talking about CPU and memory, I mean, think about it. I mean, if you're talking about CPU, memory, and a PCIe bus, how in the world can that, we have Ethernet fabrics today of like 25.6 terabit switches, right? I mean, that's a thing now. I mean, you have larger. I mean, it's all the fabrics are always going to keep getting faster and faster. Now, keep in mind when I said the 25 terabit fabric, that's with 400 gigabit connections, right? So it all depends on if you're looking at. I mean, you have to look at. Are you talking about from a WAN perspective or a LAN perspective?
From the LAN perspective.
From the LAN perspective.
They're not part of that HPC architecture.
Gotcha. From a LAN perspective, everything there is always going to be as basically the minimal amount of oversubscription. And you basically want to have a cloth fabric where everything can talk to everything as much as possible with little to no oversubscription. In fact, there may be some undersubscription where you basically over provision based on what you need because you don't always get 100% efficiency. I mean, like for example, LACP. I mean, let's say you have 16 links, you're only going to get 85, 90%, depending on how the hashing goes with the tuples.
Oh, right.
So, with that being said, it's also a function of cost. So if you're put on your business hat and say, if I over provision, how much is that going to cost, right? That's an exercise of, budget and things well out of my control, right? But those are the things that I would think about if I was doing that type of thing, if that answers your question.
It does. Thank you very much.
Thank you. That was a very good question.
Thanks.
Eric, any questions from online? Any additional questions? Yeah?
Yeah, well,
Yeah.
Come on up.
From anybody but Will.
how dare you? We love Will. Stop it.
This will be a good one. So, a lot of what I've heard is coming from the realm of real science, real problem solving, but we also live in this world of TikToks and polarization. And like one example is like my grandmother, who can not even install updates on her laptop, knows what ChatGPT is. And what it can describe it, So with all this polarization, all this social media, all this this stuff that takes so much attention, do you think that impacts the science of these things in the future and actually stymies innovation and slows things down? Or
Wow.
I just see a lot of that, and I'm just curious,
Yeah, that is a tough one to answer. It's a very good question, but the polarization. I mean, that is a whole other can of worms in itself, right? That's a lot of education, and I saw a thing recently. Was it called Ground News, where it will basically show you different perspectives of the same story and give you a weighted.
Oh, wow.
That type of technology is actually a very good, because it'll say, hey, this was shown by this political party X number of times, and they'll do, and they'll actually show services like that. Give me hope for humanity in the future. That it will help people have find what's real and what's not real, and kind of help reduce the spin and let's just talk about facts, because really science is all about facts. Don't not based on emotion, not based on what you want. What reality is, right? I mean, we have to make decisions based off of empirical evidence, and that's not always right. We have to understand that, just because we're not always right, it's a self-correcting process, and that's how. I mean, that is the process of that drives innovation, that drives progress. That's my thoughts on that. I mean, does that kind of answer your question?
Yeah.
Well, and that's the challenge, right? This is something that
you.
Andy was really championing this week, is making sure it's going to get harder and harder to make sure that the facts are really facts as we get into developing AI.
I mean, even look at interpersonal relationships, right? I mean, we're all humans. We're all going to have good days and bad days. I mean, it's a matter of perception of, figuring out facts from emotions. I mean, feelings. I mean, it's that's it in its most simplistic form.
Well, the AI doctor, the presentation the other day, he showed a deep fake that they made just with a still picture.
It's Dr. AI.
Dr. AI.
I forget his name.
Dr. Bagoli, Edmund Bagoli.
Okay. But he actually had that.
Yeah.
I'm glad he touched on it. That talk was very transparent, and they talked about some of the concerns that we have. But sometimes you don't hear that when people are like, AI is the best, and yay. And so he pointed some of that out, and he said, it's going to be increasingly more and more difficult to determine truth from fiction, and you'd have to pixel peep to see the differences, and nobody can do that.
But is that not a little bit of human nature with tribalism? I mean, we see what we want to see, and sometimes it's hard to accept what we don't want to see. Yeah. I mean, that's tough, right?
Will, when did you get your doctorate in philosophy? That was deep as hell.
I swear, we've only touched this much, I swear.
What's in these drinks?
I know, right? Any additional questions?
Yeah. Great question.
Yeah, come on up.
Yep.
Hello, my name's Travis, and I don't have a lot of exposure to the network side of these things, so I'm trying to extract some value in some other ways. How has your professional life changed? How does your work change now that you have access to large language models like ChatGPT and things like that?
So I'm always learning new technology. I'm always studying. I'm always labbing. I'm always looking at where I think is beneficial for, how much time did I put into it. My big focus on learning is automation and where I can save time in doing routine tasks. Now, AI, where I think it has the potential down the road, and I don't think it's there yet, would be helping networking proactively. I mean, technically, networking today, we have pretty good proactive monitoring, right? I mean, it's a matter of, I can pretty much tell you when a fiber is going. If you start seeing errors, you pretty much know, hey, it's time to get this out of service. We did the same thing with modems way back when, but it's a matter of tooling, right? So back to your question of when we will use tools like that will probably be a time-saving feature where, let's say that, okay, something has gone horribly wrong, or I need to go out and touch multiple devices at the same time. This is actually just network automation and not really so much AI. But if I knew strategically to go out and grab all these commands and look, let's say I'm looking for something, let's say I'm troubleshooting, that type of thing was really just automation helping me to work more, helping the networking team work more efficiently in whether we're troubleshooting or information gathering, right? As opposed to, because if I have to sit and think, if I have to log in to hundreds of pieces of equipment and issue a command and grab that data, it's a lot easier to have something help me grab that data and go out and help me visualize. So if I could step back now, if the AI could also help analyze that data and help sift through it, that's a huge win right there. If it can help, if the AI can help, anything that's a time saver, right? I mean, that's would I use something? So I saw a demonstration of this used for helping design a network, and it was probably right about 90%, but there was some critical errors, and it's that would shocking, right? I mean, but it's impressive that it can do what it can do, right? But I wouldn't trust it inherently. It's trust but verify, because if I could use that, it's like, oh, this thing just saved me 20 hours of work. That's great, right? But I wouldn't want to give it the keys and say, here, go have fun, right? I'm going to sit here and not do anything.
Well, did Dr. AI say you could put a sticker on something and AI thinks it's a pineapple?
Yes, yes,
Right?
yes.
So one thing for me too, I don't know if it was directed up towards all of us or not, but for me, I'm not a developer, and so piggybacking off the automation side of it, Python and Ansible and other things, but it has helped me figure out how to write a script to do something where he's talking about modifying 100 devices, right? And so not knowing not knowing Python at a deep level, I can go to ChatGPT or something like that, and you gotta be careful about security with that, right? Because you don't want to put anything proprietary in there. But I can open up ChatGPT and be like, look, I need just something simple like 24 ports on this switch need to be accessed with voice, and I need 2 trunk uplinks. Give me a basic configuration of that in a Python script, right? And it can put that together. Again, you have to verify that stuff, right? There's some tinkering, but it saves so much time in getting just the basics of it, right? That kind of thing.
Can I ask a follow-up to that?
Please. Yeah.
So, do you ever feel, guilty for, utilizing knowledge that's not yours? And I know that sounds like a goofy question, but I feel like
We're in IT. We Google everything.
Well, it's not just Googling, right? I mean, it's open. There's a lot of open source. I mean, I will go out and look for stuff for inspiration, right?
Yeah.
Why reinvent the wheel?
Yeah.
Give credit. Give credit in your code. Hey, I found this great link. I found this information here, and share it. And say, and sometimes I'll reach out and say, hey, this was, you really helped me out here. Thank you very much.
Yeah.
That's the beauty of open source.
Also, for me personally, if you asked me that question 10 years ago, yes, I would be ashamed of that. But as I've become more of a mature engineer,
And have scars.
I've tried to put my pride away to the side, kind of thing.
Perfect.
Well, just go to Reddit. I mean, how many people just go on Reddit forums and just ask questions, and then you spend hours just searching through all the comments and finding an answer for a problem you
I
have.
feel like everything great in humankind is built on the shoulders of giants that came before. That might be a quote that I just stole from somebody. But so it's a reframe of, am I stealing things from other people that did things before, or am I taking what we know and then building upon that? So I don't know if it's another way of looking at it.
Sure.
And one thing too is look at it from even your management's perspective, right? If you've got someone on your team that decides they're going to take several weeks to try to figure something out like that, it would take me weeks to just sit there and try to figure out the Python to get, in my earlier example. But if it takes me just 3 hours to get this going and get something functioning, I mean, how does management view that? Wow, you just knocked that out very quickly.
You have to weigh the short and long-term benefits, right?
Yeah.
But
Over time.
I mean, here's the thing. I mean, you would test that out in a dev environment to make sure that it does what you think it.
Would you,
if you're
Dan?
running-
Would you?
You don't know me.
That's Send It Richards.
Dev is production, right?
Nice.
So
It's
I-
only test until it works.
Okay, fair enough. No.
So I think this year we've started to see and hear the promises of what AI could bring IT practitioners. We were at NFD earlier this year, and they were talking about utilizing AI and data lakes to truly proactively identify parts that are about to fail and send you a replacement before it fails, so you could schedule a maintenance window and swap it out. Before, even 5 years ago, proactive meant we saw it fail, we sent you an email that it failed, and we already sent the part. You're going to have to replace it when you get the part, but it still failed, and I'm still down.
Good luck, buddy.
Yeah. So it's really interesting to see what's coming and what's possible.
Some devices have always sent telemetry, And some devices will basically, it's trending and analysis of logs. Hey, the voltages keep dropping. They know this device is going to fail. It's the power supply. So, I mean, some of that stuff is just trending, right? I mean, we've had those tools for years.
Very good. Great question.
Yeah, thank you. Thank you very much. Any other questions? All right, well, I think now it's the time that a lot of you have been waiting for. We're going to do some giveaways. Our sponsors have very generously stepped up to donate some fabulous prizes. Open Gear is giving away a tablet, and Paul Shaffron. Is Paul in the room?
Paul?
All right. Hey. Yeah. If Open Gear can come on up and... Sorry, we should have given the sponsors a little bit more of a heads up. That we're about to do this.
Sorry, Bob.
We are professionals.
Tim, if you could be so kind as to grab that A1 backpack, we're going to give...
I'm going to fall off the stage, I told you.
Hold my beer.
Yeah.
All right, and Alkira is generously brought us a PS5, and our friend Kaon from the New York Times. I'll bring it home and I'll ship it to you. It's fine, I promise.
No,
You'll see that.
Thank you.
All right, so again, big thank you to our sponsors for helping us put this on. Big thank you to KTech for inviting us, and I mean, you guys did all the event planning. Thank you so much for taking care of that off our shoulders. So this has been a great time. Thanks for all the questions, and we'll see you next time on another episode of the Art of Network Engineering podcast. Please join us outside. If on the way in you walk through a nice little rock garden, please join us out there for some drinks and hors d'oeuvres.
Hang on, am I the only one that noticed that at every live event we do, we have to put Dan and Andy at separate tables?
It's protocol.
It's protocol.
Thanks, everybody.
Thank you. A1 policy.
Man, that went by fast.
Buddy, great job. Hey everyone, this is Andy. If you like what you heard today, then please subscribe to our podcast in your favorite podcatcher. Click that bell icon to get notified of all of our future episodes. Also, follow us on Twitter and Instagram. We are at Art of NetEng. That's Art of NETENG. You can also find us on the web at artofnetworkengineering.com, where we post all of our show notes, blog articles, and general networking nerdery. You can also see our pretty faces on our YouTube channel named The Art of Network Engineering. Thanks for listening.